Welcome to this week's episode, and today we will explore the question, what is the difference between RAG, the architecture we investigated last week, and fine-tuning? Because many customers ask me, for example, do I need fine-tuning? So in general, the first thing which is very important to understand in machine learning, that for example, if I have a problem, like a regression problem, that means that I want to predict a numerical value, that for example, I have values of a graph and I have just two data points as you see here. And now I want to predict all the points in between. This is interpolation, or for example, the points which are not in between, this is extrapolation. What I do then is that I train based on the data I have, for example, a linear regression model. And what I'm now able to do is that I'm able to predict any points between these 2 points. And in the outer, the term for this is generalization, which is the key aspect, for example, of machine learning. That means that I accept some kind of error for this ability to generalize, because this is what a machine learning model does. And I guess this is very important to understand, because this means that you accept errors, that you accept mistakes and flaws. But what you get for this is, for example, the benefit of this generalization, which you need, for example, if you want to predict some kind of result for data you have not seen before and which you did not have as training data. So, and the term for this is the so-called accuracy. So usually you have different problems in machine learning and you can divide it into supervised learning and unsupervised learning. We will not talk about unsupervised learning. This is like clustering and things like that. We put it aside. Today we will look into supervised learning. And these problems that you have there is regression, what we have seen before, for example, linear regression, where you try to interpolate points between labeled data, between data points that you have seen before. And for example, classification, that means that you have categories, like for example, images like a cat and a dog image, and then you try to classify, for example, based on the data that you have, is it a dog or is it a cat? So, and now we use this classification problem for investigating accuracy, because it's pretty easy to explain based on this. And first, what you have, the accuracy means that you investigate, for example, how good is your detection in terms of the overall data points that you have. This is accuracy. That means how accurate you are able to detect the true positives, the hits, and the correct rejections. This is the sum in the denominator and divided by all kind of true positives, true negatives, and so on. So, and now the question is, for example, why is accuracy not enough? And usually what is a good example is like, for example, fraud detection. In the field of fraud detection, for example, if you have fraud in the banking industry, what you want to detect is, for example, any kind of fraud. That means that, for example, if the false negative rate too big, that means that you misses real frauds, then you have, for example, a big damage. And this is why you really try to optimize your method in a way that you will not miss any kind of potential fraud. So you accept to detect, for example, false alarms rather than having, for example, not this misses, this underestimation. In terms of manufacturing or medical diagnosis, for example, what you try to do there is to minimize the false positives, because if you have too many false positives, too many false alarms or overestimation, that would mean that, for example, you waste money, that you have unnecessary treatment and expensive, for example, in the field of medical diagnosis. On the field of manufacturing, you also would have unnecessary expensive. So this is the trade-off you try to achieve. And the basic step about this is, for example, if we now talk about RAG and fine-tuning, that you as a customer have to think about, for example, what kind of accuracy is good for you, is enough, because then you can stop your optimization journey. Because the question about LLM optimization or context optimization arises when, for example, you want to find a solution for a problem that you have. And this is why you have to think before, ahead, for example, what is a good accuracy to achieve? And then you can start this optimization journey. And for example, you always use RAG if you try to optimize your context, if you want to bring, for example, data and information into your data challenge. And LLM optimization means that, for example, you try to optimize the LLM in a way in terms of consistency, that, for example, you get consistent answers, that you always get the same syntax, structure, the brand voice, for example. This is when you use LLM optimization. My personal opinion is that, for example, the full weight optimization in terms of LLMs, currently it does not make sense to put money into this because the development in terms of LLMs currently is so fast, for example, in the open source section with the Llama models, that it would be a waste of money. But for example, there are optimization methods for LLMs like LoRa fine-tuning, which is an acceptable way of doing fine-tuning. So context optimization is as follows. Usually you start with the prompt. So prompt engineering is the most important part. And if you see, for example, that the answer you get in terms of your prompt is not good enough in terms of the answer consistency, what you do then is, for example, that you give the LLM some examples, some few shots like your answer should look like. And based on this, you can increase the answer consistency. If you see that your prompt gets too big, for example, that it is restricted in terms of the number of chars you can feed in, what you do then, you split it up. And this is where you more or less use the very hip so-called agent architectures. That means that you split your prompt up into some smaller prompts and you call them agents. If you see then that, for example, the context or the quality of the information is not good enough, you work on the context optimization. That means that you add in RAG architecture, which means that you give, for example, up-to-date information if you see that the answers are not good enough in terms of the information quality, and that you look up, for example, in databases for better answers. And this is the RAG architecture which we have investigated last time. So this is a very simple retrieval phase then, that you do more or less a semantic search. And if you see then, for example, that the consistency of the answers is not good enough, what you can do then is that you apply, for example, the LoRa fine-tuning, which means you do not do a fine-tuning on the entire matrix of the billions of parameters. You more or less decompose it via matrix decomposition, and then you optimize just a part of these weights. And finally, you can use your old weights and just add them up. So it's some kind of minimal fine-tuning that you can use, and you do not need a lot of training data for this. And if you see then that, for example, still the quality of the answers is not good enough, what you can do then is some kind of height retrieval. That means, for example, that you add some kind of document search, that you give the LLM not few shots as answers, but few shots documents. That means that you make up a hypothetical document response, and based on this response, like it should look like, the system is able, for example, to mingle or to mix all the output it's get from the RAG architecture and optimize the output it gives to the customer, to the user. So, and based on the answer that you get then, for example, you could do a further fine-tuning, but all of this you just do as far as, for example, you achieve an accuracy, a recall, a precision, which is good enough of a use case. This is very, very important to keep in mind. So I hope you enjoyed the episode of this week and you learned something about RAG and fine-tuning. If you have any questions, reach out to me. See you next week.